Today we will be talking about botany on Mars and how essentially we as humans could have the potential of turning over a new leaf.
There are some key differences between the soil in Mars and that on Earth. Firstly, Earth's soil contains mineral matter, organic matter, air, and water, whereas Mars soil is made up of mostly mineral matter and only 2% water. There is no air in the soil or organic matter, given that there are no living things to make up the organic matter. Earth's soil, on the other hand, contains animals such as earthworms and microbes that aid plant growth. By definition, soil must contain organic matter. Therefore, the dirt found on Mars cannot be classified as soil, but rather as regolith, referring to a loose material covering the surface regardless of organic matter. Despite not having the essential organic matter needed for plant growth, all the nutrients needed for plant growth have been found in Mars. The soil must be fertilized in order for needed nutrients such as nitrogen, potassium, and phosphorus to be available. Some scientists from the Netherlands managed to use a Mars-like soil substance to grow plants by using freshly cut grass as their organic material. The growth of plants on Martian soil is possible, yet the soil on Mars contains toxic material called perchlorates. Yet this problem can easily be fixed given that perchlorates can be easily removed by simply washing the soil. Once the necessary changes have been made to the soil, osmosis, the diffusion of water into the plants due to movement towards the solvent, should work the same way on Mars as on Earth. The atmosphere on Mars and on Earth also have some significant differences, making plant growth more difficult on Mars. The surface temperature on Mars is significantly lower than on Earth, reaching its highest summer temperatures at about 70 degrees Celsius. Because of this difference in temperature, a Martian garden would need protection from the cold, as many essential nutritional crops require heat to grow. Artificial sunlight may also be needed, given that some plants require plenty of sunlight in order to sprout, and Mars receives less sunlight than Earth, given that it is further away from the sun. An enclosure may be needed to be made, mimicking a greenhouse in which the atmosphere can mimic that of the Earth's. Mars' atmosphere is also mainly composed of carbon dioxide, which is a significant difference to Earth's atmosphere, as Earth is mainly composed of nitrogen, which is essential for plant development. Gravity on Mars is also only around 38% of that on Earth. This will affect the circulation of air on Mars, reducing it and limiting the plant's ability to take in CO2 and release water through transpiration, which is a problem as transpiration is essential for the uptake of nutrients from the soil as water travels from the roots to the shoots, carrying the nutrients in the solution. A research team from Osaka found that in zero gravity, plant transpiration decreased by 46%, and there was 20% less photosynthesis, therefore proving that gravity plays a major role in the regulation of plant transpiration and photosynthesis. As I had mentioned before, the soil on Mars is composed of 2% water, meaning that Mars is extremely dry. Mars does contain solid water in the form of ice, yet it contains very little liquid water. The water that is found on Mars, however, is too salty and scarce for plant growth. Therefore, water from Earth must be transported to Mars. There is also no water-based precipitation on Mars. Therefore, scientists believe that the water found in its soil is absorbed from the vapor in the planet's atmosphere. The difference in gravity may also affect water transport in plants. Water molecules will contain the same properties of adhesion and cohesion, yet the hydrostatic pressure of a plant may be affected, given that gravity affects the movement of water in the xylem. The major factors influencing water potential in plants are also concentration, pressure, and gravity. Gravity also plays an important role in the drainage of water. Therefore, the change in gravity could potentially affect the plant's response in regards to their intake of water. However, gravity could also affect the amount of water needed, as water will flow differently through Martian soil. Because gravity is lower on Mars than on Earth, the soil will be able to retain more water. The nutrients within the soil will drain away more slowly. Therefore, it's possible that less water will be needed in order for plants to be watered on Mars. The growth of plants is strongly influenced by the environment, as stems grow upwards against gravity, while roots grow downward with gravity. Yet the gravity on Mars is much less than that on Earth. Therefore, this response, known as gravitropism, will be affected. In 1998, Hideyuki Takashi investigated the behavior of plant roots under different gravitational conditions, and discovered that the roots were more likely to bend in response to humidity in the environment, displaying a more pronounced hydrotrophic response rather than the gravitropism found on Earth. The auxins, the hormones that encourage roots to grow downward on Earth, encourage the roots to grow towards water in space, suggesting that hydrotropism is enhanced in the absence of gravity. Thigmotropism, the movement of a plant in response to touch stimuli, is not expected to change under Martian conditions. There is also less sunlight on Mars, therefore the effect of phototropism, the response of plants to light stimuli, may not be as strong. The day length on Mars is actually very similar to that on Earth. A day on Mars is only about 40 minutes longer than a day on Earth. This means that the day-night cycle flowering may be similar between Earth and Mars. However, it is important to note that the intensity of sunlight on Mars is much less than that on Earth. This might affect the cycle of phytochrome in the plants, given that the amount of phytochrome red and phytochrome far red are produced in response to sunlight and are essential for plant flowering. Large amounts of phytochrome far red are produced during short periods of night darkness, promoting the flowering of long day plants, whereas short days and long periods of darkness will result in the production of less phytochrome far red and more phytochrome red, promoting flowering of short day plants. In order for these cycles to continue and for flowering to occur, there must be a certain cycle followed in regards to the amount of light the plants receive. For this reason, the change in light intensity may affect the flowering cycle found on Earth.
We know Earth's seasons to consist of winter, spring, summer, and fall. Mars, in fact, has all of these seasons as well. However, Mars has a longer year, and therefore the axial tilt is different, as well as the orbit, Mars having a more oval-like orbit, while Earth has a more circle-like orbit. These tilts and orbits are influential to the timing of the seasons, as Mars's orbit develops uneven seasons, spring being 7 months, summer 6 months, fall 5 months, and winter 4 months. Despite the longest seasons being spring and summer, Mars's temperatures remain cold compared to Earth's warm and even hot summers, affected by the equator, of course. On Earth, areas close to the equator can withstand temperatures that are sustainable for plant and animal life. Without plants and animals, unlikely to survive in cold temperatures, there would not be effective seed germination nor pollination to incite seed germination. Seed germination is essential for plant growth and requires a specific water amount, substantial oxygen, and a comfortable temperature. On Mars, it would be very difficult for many plants to germinate, as most plants require consistent watering and effective amounts of oxygen. The temperature would also prove to be an obstacle on Mars, as the temperatures only reach 7 degrees Fahrenheit as the maximum. Micropropagation is what we know to be the process of developing large quantities through the cloning of stock plants, which are plants that are produced simply in large quantities. Micropropagation is something people do on Earth because of the high demand for certain, easy-growing plants or vegetables such as lettuce and tomatoes. Samples of vegetable plant tissues agar medium with nutrients, and then once they are formed, they are grown in compost, which is creatable on Mars. Once roots and shoots are developed, the cloned roots and shoots can be transferred to soil and effectively grown. This process does not have specialized or extraneous conditions and therefore would be ideal on Mars, as we can bring lab materials for micropropagation and grow them successfully in labs that we would be able to establish on Mars. Micropropagation would be an important asset on Mars, as it would help to develop more oxygen for humans as well as supply us with new food sources. Potatoes have the potential to be grown on Mars during the summertime, as they are preferably grown in cool temperatures, from about 45 degrees to 80 degrees, which is a very flexible range for effective germination of potatoes. Potatoes can be easily micropropagated through planting seed potatoes, potatoes that are whole or a piece of potato with an eye. They do not need an abundance of water, which is ideal for Mars conditions, yet do require their soil or foundation to be moist. Nitrogen levels must be kept low, which is ideal for Mars as well, considering that the atmosphere is only 2.7% nitrogen. Potatoes are also very nutritious for the human diet, as potatoes are a good source of vitamin BX, fiber, magnesium, and serve as antioxidants. Carrots, similar to potatoes, thrive in cool conditions and therefore would thrive during the summertime on Mars. The soil does not need to be watered excessively. They can grow in loose, sandy foundations as well, meaning their conditions aren't overly specialized. They should not be grown with fertilizer, making their requirements even less needy. Carrots are frost tolerant and are actually preserved in frost, which is paralleled with that of the other weather conditions of Mars. Carrots are important for humans because they contain vitamin A, antioxidants, and other nutrients. Many antioxidant-rich fruits and vegetables like carrots help reduce cardiovascular diseases and cancer, and also improve eye health. Artificial light would be necessary to grow green beans, as well as heaters to sustain warm temperatures. They should be grown during the summer of Mars, if at any time. However, green beans can be easily micropropagated and are extremely nutritious. Another benefit to growing them on Mars is that they do not require moist and wet foundations, Essentially, they can thrive in dryish, crumbly soil, a consistency of soil that can be easily sustainable on Mars, yet every so often watered. Green beans are of great nutritional value as they are a good source of fiber, potassium, folate, protein, iron, and zinc. Many of these elements are nutritional and form to create antioxidants called catechins, which can improve heart health and help prevent cancer and manage or prevent diabetes. Tomatoes, similar to green beans, will need artificial light on Mars as they are in need of long hours of exposure to light. Their nutritional value is outstanding and thus would prove beneficial to human life on Mars, providing lycopene, which is an instigator of antioxidants and a fighter of cancer, beta-carotene, flavonoids, vitamin C, and hydroxycinnamic acid derivatives. Tomatoes have already been discovered to be easily micropropagated through biotechnology, as it is a highly demanded product that has seedlings that can be easily reproduced. Because artificial light serves as a substantial energy source and substitution for sunlight, the plant would do well on Mars. Tomatoes do need regular watering but can thrive off of heavy composting.
Because rye is one of the most resistant crops, it is one of the best plants to grow on Mars. This crop is able to adapt to different soil types as well as cold and rainy weather. Rye is resistant to low temperatures that fall down up to 20 degrees Fahrenheit. Rye also only requires moderate watering as it has powerful, highly developed root systems and a smaller foliage than any other cereals. Rye is also very nutritious as it is packed with magnesium, which optimizes heart health, fiber, which can reduce cholesterol, and high levels of iron, calcium, potassium, zinc, vitamin E, and a variety of B vitamins. Rye also contains phytoestrogens, which has shown to improve hormonal balance.